Hi students, welcome to today's class. Today we are studying about syndrome and error detection. Okay, so by using syndrome, by calculating syndrome, we can detect the error. In the previous class, we have already studied what is linear block code and how we are writing, how we are finding a code word from linear block code, that is an encoding of linear block code, etc. So this is all happening in the transmitter side, that is before transmitting through the channel. So before transmitting to the channel, the information, the message is going through channel encoder, and the encoding process is done there, and the output of encoder we get the code word. So we have found how to get the code word, okay, from message bit. So from k bit, by adding parity bits, we get the code word. So this code word is transmitted through the channel, and we have received this code word as R. So we are transmitting code word C, and we are receiving at the receiver by the letter R. Okay. So this is syndrome calculating and error detection is happening in receiver side. So after receiving the value after receiving the value R means received vector, by transmitting code word C, there will be some error occur in C. So the R received will be a derived version of C, that is C plus error. So by calculating the error, we can find which code word is transmitted. Okay, so this is a method for finding the error, that is syndrome. Consider an n comma k linear code with generator matrix G and parity check matrix H. Let C is equal to, that is code word is equal to C0, C1, etc., C minus 1 be the code word that is transmitted over the noisy channel. Let R equal to R0, R1, etc., Rn minus 1, which has same size of C, because C is transmitted and R is received. Will be the noisy version of C. Okay. So Rn minus 1 be the received vector at the output of the channel. Because of the channel noise, R may be different from C. So because of channel noise, R is different from C. If we transmit C, if we get C itself, there is no error. If we transmit C, we get a data R. So R may or may not be C. If R have errors, it is not equal to C. If R have no error, it will be equal to C. So we have now at the receiver side, we have only we have only R, received vector R. So we have no idea about transmitted code word C. So at the receiver, we only have the vector R. Okay. So this is the figure when C is transmitted. Okay. When C is transmitted, we get an R through an additive white Gaussian noise. This channel will be adding some errors. So the R will be noisy version of C. So R is equal to C plus E and error E. So E is equal to error vector or error pattern. So E is equal to E0, E1, etc., En minus 1. E also has same size of R and C. Okay. So here, this is modulo to addition. So we can, there is no subtraction sign here. So we can change to any direction. So R equal to C plus E. Then we have E is equal to R plus C. So we get E from R plus C. So EI equal to 1 or EI equal to 0. EI equal to 0 means CI and RI and CI are same. That is no error. If EI equal to 1 means there is an error, that is RI not equal to CI. Okay. The receiver doesn't know either C or E upon receiving R. Okay. The receiver is nothing, doesn't know about the details of C or E. It only knows the value R. Okay. The decoder must first determine whether R contains transmission error. Okay. If the presence of error are detected, the decoder will either take action to locate this error and correct them, or request for retransmission of C. Okay. The duty of the receiver is, after receiving R, its duty is to find whether this R contain error or not. if errors are detected, then the decoder either take an action to remove this error, or it will request the transmitter to retransmit it. Okay. When R is received, the decoder compute the following, that is n minus k tuple. That is, we have, if R is received, we doesn't have any information of C and error, that is transmitted code word and error. So at the decoder side, it will calculate a term syndrome. That syndrome S is equal to R into H transpose. We have generator matrix G and we have parity check matrix H. Then from this we can find H transpose. So at the receiver section, or the decoder will produce an n minus k tuple called syndrome, which is equal to R into H transpose. This S has a size of S0, S1, etc. n minus k minus 1 size of the parity bit. Okay, it has n minus k size. So it has values from S0 to Sn minus k minus 1, which is called syndrome of R. So by receiving R, we should find the syndrome for R. Okay. So syndrome is equal to R into H transpose. We have R is equal to C plus E into H transpose. Okay. That is C plus E into H transpose. Now we are opening this bracket, we get CH transpose plus EH transpose. We get CH transpose plus EH transpose. We have already found that CH transpose is equal to in previous session. Then we have EH transpose. So syndrome is equal to EH transpose. So we got two equation for syndrome. Syndrome S is equal to RH transpose and syndrome S is equal to EH transpose. Okay. Syndrome equal to 0 if and only if R is a code word, that is no error. If syndrome is not equal to 0 if and only if R is a code word. Okay. So this is the case of syndrome. Okay. Next we are going to find the syndrome calculation circuit of a linear block and comma k linear block code. So we have R0, R1, R2, etc. up to Rn minus 1, and we have the p value. Okay, p matrix. That is, we have G is equal to Pik, H is equal to In minus k p transpose. From this we get H transpose, we get I a column matrix. This row matrix will be converted to column matrix and the P transpose will be removed. So H transpose is equal to In minus k p. So we have S is equal to R into H transpose. So by receiving R, we want to multiply H transpose. H transpose is nothing but In minus k p. So we have P is equal to P00, 01, 02, etc. 0 n minus k minus 1 and this value. Okay. So by multiplying this P with the R, we get syndrome. So by taking R value, we have P here, P01, P02, etc. P0 k minus 1, and here etc. P0 n k minus 1, this value. By adding these P's are a connection of R to S. So by calculating this value, that is by calculating S is equal to R transpose, we get the value syndrome values S. Okay. So we get a syndrome equation. From that syndrome equation, we are finding this circuit. So by adding these values, we get S0, S1, etc. Sn minus k minus 1. This is how we are calculating a syndrome. So we can discuss, or we can see a example for this syndrome calculation circuit. Okay. Now we are calculating the syndrome calculation circuit for 7, 4 linear block code. Okay. So we are only provided with the received vector R, which is equal to R0, R1, R2, etc. Rn minus 1. Okay. And we have syndrome S is equal to S0, S1, S2, etc. Sn minus k minus 1. So since the code word is of n numbers, the received vector is also with n numbers. Okay, so the size of code word is n, so the size of received vector is also n. So we have for n comma k, that is 7 comma 4, here we n equal to 7 and k equal to 4. Therefore n minus k is equal to 7 minus 4, that is equal to 3. So we have the syndrome value up to Sn minus k minus 1, that is n minus k minus 1 is simply S2. So the syndrome have values S0, S1 and S2, and here since here n equal to 7, the received vector R have values R0, R1, etc., R6 Okay, now equation for syndrome S is equal to R into H transpose. We have given H transpose is equal to 100, 010, 001, 110, 011, 111, 101. This is H transpose. By substituting we get S is equal to R H transpose. S is equal to R0, R1, R2, R3, R4, R5, R6 and the value and the matrix X transpose. So from these we are finding for S0, S1 and S2 equation. Okay, so what is the equation for S0? This row multiplied by this column. So R0 into 1 we have R0 plus R1 into 0 it will be 0, R2 into 0 will be 0, R3 into 1 we have R3 plus we have R4 into 0, then R5 into 1 plus R6 into 1. So we have R5 plus R6. So this is the equation for S0, that is R0 plus R3 plus R5 plus R6. Now we can go to the equation for S1. So this R value into second column. So R0 into 0 will be 0. R1 into 1. So we have R1 plus R2 will be 0, then R3, R4, R5 will be there. So R3 plus R4 plus R5, R6 will be 0. So the equation for S1 is R1 plus R3 plus R4 plus R5. Then the final equation that is for S2 is we have the first two term will be 0. Then we have R2 plus then the fourth term also 0. R3 will be 0. Then we have R4 plus R5 plus R6. R4 plus R5 plus R6. So the equation for S2 is R2 plus R4 plus R5 plus R6. This is R5, R5 plus R6. Okay. Now we are going to draw the syndrome calculation circuit for this H transpose. Okay. Now first we have R0. Okay, R1, R2, R3, R4, R5, R6. So we have 6 received vector R0 to R6. Okay, now what we are going to do? We are going to take these values. Okay, so there is connection with all these values. Okay, now by taking the value, by how we get the syndrome S0, we get syndrome S0 by taking R0 modulo to addition of R0 plus, sorry, not R2, R0 plus R3, output of R3 plus, then we have R5. R5 plus we have R6. So this is how we get syndrome S0. Okay, this is S0. Then we want to find S1. S1 means nothing but modulo to addition of R1, we have R1 plus R3, we have R3 plus R4 plus R5. Then we get the output S1. Okay. Then the output S2 we have modulo to addition of S2 is R2 plus R4 plus R5 plus R6. We get S2. This is how we will get the value of S0, S1 and S2. So by So this is S0, S1 and S2. So this is the output for syndrome. Okay. Now let R received. Suppose in order to get the correct code word, this syndrome will help to get the correct code word. So let R is equal to, so let we are considering, let R equal to 1 0 0, this is the received vector, 1 0 0 1. So let R equal to received vector is 1 0 0 1 0 0 1. So we want to find the error. By finding the error, we want to find the code word. So the equation for code word is, that is C is equal to C or V. These two variable can be used for equation for code word. C is equal to R plus E. Okay, this received vector plus error. So we want to find the error vector. Okay, so error vector can be found by this value by finding the syndrome. So we have equation for syndrome is S is equal to R into H transpose. Okay, so we have S is equal to, we have R 1 0 0 1 0 0 1 into H transpose. So the value of H transpose is 1 0 0 0 1 0 0 0 1 1 1 0 0 1 1 1 1 1 and last 1 0 1. So this is the equation for syndrome calculation. Okay, so we can find the syndrome by syndrome S is equal to, there is one, look at the ones in syndrome. So this 1 into first row. So easily we can find syndrome S is equal to 1 into first row. We get 1 0 0 plus 0 into second row will be 0, 0 into third row will be 0, 1 into fourth row we have 1 1 0, 0 into fifth row, 0 into seventh row, 1 into last row plus 1 0 1. So this is the easy way to find the syndrome. So we have 1 0 0 plus 1 1 0 plus 1 0 1. So by adding these three can be added here. That is 1 0 0 1 1 0 1 0 1. Okay. Then by adding these we get 1 1 1 plus 1 is 0, 0 plus 1 is 1. So the syndrome value will be 1 1 1. So we got syndrome as 1 1 1. We can find syndrome by substituting these vectors in the syndrome equation S0 S1 S2 also. We get the same value. Okay, so we have syndrome equal to 1 1 1. Now how we find the error from here? By finding the syndrome we can find the error. So we can find error is equal to, by finding the syndrome, please look at the H transpose value. So find out the syndrome in H transpose. We have syndrome 1 1 1. So we have in H transpose the same here, that is 1 1 1. Okay, this is 1 1 1. Now we can find which position is this value 1 1 1 in H transpose. That is 1 2 3 4 5 6. This is sixth position. So we will have an error in sixth position. So 0 1 2 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Okay, so the error will be this. We have an error. This method only shows the 1-bit error only. So if there is a 1-bit error, we can choose this method. Otherwise, we cannot choose this method. So we got an error in the 6th bit. So we are writing all others are okay, but an error occur in the 6th bit. So 7, 2, 3, 4, 5, 6 bit an error. So from this, we can simply calculate the value for code word, or the code word C is equal to error plus, that is 0 0 0 0 0 1 0, this error plus with received vector, that is 1 0 0 1001. So these all are okay. The second last bit is have error. So the output will be 10010. By adding this we get 1 1. So this is the transmitted code word 1001011. So this is how we are calculating the code word from syndrome. By calculating syndrome from the equation S is equal to RS transpose, we get the value of syndrome. By getting the syndrome value, we will search the value in S transpose by which position it is happening. So by finding the position, it is in the sixth position, the error will be in the sixth position. By adding this error with the received vector, we will get the transmitted code word. So this is how we are calculating the transmitted code word from the syndrome. So that's all about today's class. Thank you.